And among the items, okay, just some of this you have likely seen in previous math courses, but just some of you might be looking at the items for the first time within certain parameters, but in some way, shape, or form, you've seen it in various capacities. Okay, and we have just at the start we have for the introductory material. Okay, so we have looking at multiplying polynomials. And for multiplying polynomials, okay, a common approach, okay, is referred to as the FOIL method. And that's an acronym for first, outer, inner, and last. And for the FOIL method, okay, we have just the traditional approach. Okay, we have like you can have a couple of two-term expressions. Okay, and we have in the form of a plus b in parentheses, along with c plus d. And if we're looking at multiplying, what we have here, okay, like if a plus b cannot add together as a single term, and c plus d cannot be added as a single term, and we try to multiply these expressions out. Okay, common approach is to multiply the first terms together to start off. Okay, so you have a times c, and then we have the terms most distant from each other, so we have plus a times d. And then we have the separated terms but closest to each other to multiply together, so you have b times c. And then we have the last terms from each of the groups, okay, to multiply, whereupon we have b times d. Okay, so again, FOIL had first terms, outside terms, inside terms, as well as the last terms. And there is another approach or another layout, and you have probably seen this or in the form of what is commonly referred to as the box method, and this is what's referred to as the geometric FOIL approach. And for the geometric FOIL method, so if we're looking at multiplying the same sets of terms, and you can set this up as a matrix. And it really doesn't matter which you're going to have as the row headings or the column headings. Okay, so you've got a plus b, so just let a and plus b represent the column headings, and c and plus d represent the row headings. Okay, so looking at what we have inside each square, okay, you're looking at multiplying the corresponding parts. So you have a times c, and going down the first column we have a and plus d, so you have plus ad. Then for the second column at the top we have plus b times c. And then we have, for the last square, we have b, positive b and positive d, so you have plus b times d. And so in the arrangement for the FOIL, you still come out to AC plus AD plus BC plus B times D. So either approach is viable. Okay. And just looking into applications of the FOIL. See, we have a couple of expressions, and we'll say that we have as a first case. We can say we have the quantity 3x plus 4 times that of x plus 7. Okay, and if you see the result right away, that's fine. But just looking at so you have a couple of two-term expressions. So you have a plus b, c plus c. A plus b is represented by 3x plus 4. C plus d is represented by x plus 7. So representing a times c. Okay, so we have 3x times x. For the outside terms representing a times d, we have 3x times 7. For the inside, we have 4 times x. And for the last, okay, we have 4 times 7. Again, just restating. Okay, so you have the FOIL, first, outer, inner, and last. And looking at taking the products. Okay, so you have 3x times x. So this will become 3x squared. Then we have for the outside product, okay, we have 3x times 7, so this will be 21x. And for the inside product, we have 4 times x, which will be 4x. And the last part, we have 4 times 7, so this will be at 28. All right, so we have 4 terms right now, but the terms we have in the middle, okay, can be combined. Okay, so for what we have right now, 3x squared, that is the only term that is going to be second degree in the variable x. Now for 21x and 4x, now they had the same letter and the same degree. Both of these are first order in x. And so we can combine these in terms of adding. So 21x plus 4x will form 25x. And of course, we have 28 is the only constant. And so for the resulting outputs, we have a trinomial expression in the form of 3x squared plus 25x plus 28. And now for the next case, you could have also used the geometric approach for this particular example. And I'm going to do this for the next one. And let's say that if you have an exponent involved, so you have 4x minus 3y. Quantity squared. Okay, so you have 4x minus 3y to the second. Now in terms of what the 2 signifies, this will represent how many times 4x minus 3y would appear if you were to rewrite this expression solely in terms of multiplication. So for 4x minus 3y raised to the second, you're going to have this binomial, okay, to appear twice. Just like if you had 4x minus 3y raised to the third, you have 4x minus 3y times itself and times itself once again. Now, for what we have in terms of the visual layout, if I take the geometric FOIL approach, okay, so this time we have 4x minus 3y and another 4x minus 3y. So if we look at going in the form of completing as you go column by column, so you have the first section, you have 4x times 4x. 4 times 4 is 16. X times x is x squared. And then we have in the next section, we have 4x times negative 3y. 4 times negative 3 is negative 12. and just putting the letters in alphabetical order. So that product is negative 12xy. And guess what? At the top of the second column, we'll have the same product with another negative 12xy. And then we have a negative 3y times itself. A negative times a negative is a positive. So this will come out to positive 9y squared. And just foiling out and itemizing what we have here. Okay, so we have 16x squared minus 12xy minus another 12xy. Then we have plus 9y squared. And we have, in the case of the final output, okay, so 16x squared is the only term of its kind where it has the square of x. Now for the middle two terms, we have these to be first degree in both x and y, and they are identical, and if we combine together, we're going to end up at minus 24xy. And the last term is the only one we have exclusively in terms of y squared. And this will be what we have in this particular result. And say we have another set of two-term expressions. Okay, whereupon we have the quantity 3x plus 4 times that of x minus 10. Okay, so if we go with the traditional, okay, so you got 3x times x outside terms, okay, we have multiplying 3x and negative 10 inside. Okay, so you have 4 times x. Again, for the last combination, we have 4 times negative 10. So for the first product, okay, this will come out to 3x squared. Outside product, we're going to have it minus 30x. Inside product, okay, we'll have it 4x. And the last product, we have it negative 40. And combining the middle two terms together, we come out to 3x squared minus 26x minus 40. So you got 3x squared minus 26x minus 40. And let me mention something right fast. Okay, for the prior example, okay, I took the square of 4x minus 3y. And there's a name for this particular output, and it's with the raising to the second power. And for an expression like 16x squared minus 24xy plus 9y squared, this is going to be what is regarded as and again, it's with the second power. And if you have an two-term expression times itself and the output is a trinomial, we have a special category for what we have among the trinomials. And this particular output is going to be in the family of what will be referred to as square trinomials. All right. Now, in terms of working with the FOIL, tell you what, let's see what we get whenever we multiply, let's say, the quantity of 4x plus 3 times that of 4x minus 3 and also let's see what we get in the case of 3x minus 8z quantity squared. So for the next few moments, let's see what expressions we get upon multiplying what we have in these two problems. Just for what we have in these two problems, okay, so we have looking at first of all the quantity of 4x plus 3, okay, times that of 4x minus 3, and now looking at what we have in taking, we'll go with the traditional FOIL in this one. Okay, so we have with 4x plus 3 and 4x minus 3. Okay, so you have 4x times 4x. Okay, so this will be the makeup in setting up the first product, and then we have for the outside product, we have forming from the terms 4x times negative 3. Then we have with the inside, we have 3 times 4x. And for the last product, we have resulting from 3 times negative 3. And looking at what we have now, okay, so you have 4x times 4x. Okay, so this will be 16x squared. And for the outside product, okay, so we have 4x times negative 3, so this will make negative 12x. Inside product, okay, we have 3 times 4x, which will make 12x. And 3 times negative 3, okay, so this will form negative 9. And just for the results, okay, we have 16x squared. And as we combine like terms in the middle, okay, we have a negative 12x and a positive 12x. And here we're going to have additive inverses. So these are going to go out. And so instead of a 3-term expression, we end up with an expression that has 2 terms, whereupon we have 16x squared minus 9. And I will mention, if you notice in the binomials, okay, we had the same terms except we had 3 added in the first, 3 subtracted in the second. And if you have the same terms where one operation is addition and the other operation is subtraction, your output is going to be where your outside and inside products are going to cancel out. And for the output, you're going to have what's going to be regarded as a difference of squares. Like we took the square of 4x, and by multiplying 3 and negative 3, we had the negative of what was 3 squared. Right. Now for the other item, okay, so you have so we're looking at the square of 3x minus 8z. Okay, and again you can use either approach. And I tell you what, if we'll go with the geometric on this one. Okay, so for the square of 3x minus 8z, okay, so you have 3x minus 8z times itself. So just setting up the 2x2 matrix. And looking at the items column by column. Okay, so we have, first of all, okay, we have 3x times 3x. Okay, so you have 9x squared. Then we have next, we have 3x times negative 8z. So we're going to have negative 24xz. And then looking at the second column, so we have at the top, we have 3x times negative 8z, so this would be a negative 24xz. And for the last product, okay, we have negative 8z times itself. Negative times a negative is a positive. And it's come out to 64z to the second. And so just attaining the terms that we have among the inside boxes. Okay, so you have 9x squared minus 24xz minus another 24xz plus 64z squared. Okay, now we have for the output, okay, we still have 9x squared. Okay, now we have minus 24xz minus 24xz, so there's no cancellation here. And negative 24 and negative 24, okay, will amount to negative 48. And here we have xz. And again, we have the last term, we have 64 z squared. So if the outside and inside products cancel, then we'll have a difference of squares. And if you have, on the other hand, where you had the square of a binomial, where you're going to have outside and inside products to be identical, they will combine. And again, this output is going to be another sample of what we have with a square trinomial. Okay. All right, so far we've been taking expressions and multiplying, where the goal is to get to the product. Now, if you were to take the reverse route, where you might have the product itself, and the question posed would be, what terms or expressions will multiply out to get to that particular product? And so in the what might be regarded as the reverse FOIL, okay, we're going to have instead of multiplying polynomials, we'll be looking at factoring instead. And in the case of factoring polynomials, okay, and we'll start out with some samples, and we'll start out where the first term is going to be x squared. So if you're looking at multiplying a trinomial expression like x squared plus 7x plus 10, okay, and okay, so this expression can be factored, and with the leading term at x squared, okay, now that times itself, that would give you x squared will be x and x. Now in terms of the numbers that will be filled in, okay, there's a layer of 2 dimensions. Okay, one is going to be regarding multiplication, and the other one we have regarding adding or subtracting. Okay, so we have the numbers 10 and 7. Okay, posed to be the question, what 2 numbers will multiply out to 10, and that will, in terms of adding or subtracting, will combine to positive 7. And there will be 2 such numbers. Okay, one is going to be a positive 2, and the other one is going to be a positive 5. And it doesn't matter what order you place the numbers. You can have x plus 5 at the front, followed by x plus 2, regardless. The factors that will go into x squared plus 7x plus 10 will be x plus 2 and x plus 5. And let's say that if you have a polynomial and we'll have the appearance of another difference of squares where you don't have a first degree x term. Say we have x squared minus 64. And I'm just going to add this little portion here. Say we're missing a first order x term. Again, if you already see the result, okay, that's fine. But you're looking at x squared, okay, which will factor out to x and x. Now for negative 64, you're looking at numbers that will multiply into negative 64, and that in terms of adding and subtracting will combine to 0. So that means you'll be looking at the terms to wind up canceling each other. And so you're going to have equal weights for the addition and the subtraction. So you're going to have both x plus and x minus 8. Again, so x squared minus 64 is another difference of squares. Now, if we look at square trinomial, see we have x squared plus 20x plus 100. Okay, so once again, so we're starting out with x squared. In terms of factoring, this will go to x and x. And for 100, okay, numbers that will multiply into 100 and simultaneously add up to 20, then we have to be the same. So you have x plus 10 and x plus 10. And since x plus 10 appears twice, we're going to have for this particular square trinomial, writing the result in the condensed form, this will come out to be x plus 10 raised to the second. All right, so for the first and third cases, okay, we've had positive first order x terms. Second case, with the difference of squares, there was no x term. But let's say that if we have a negative first order x term, and we'll say we have x squared minus 10x minus 24. Okay, so for x squared minus 10x minus 24, okay, so we have for x squared again, we have x and x. Now for negative 24, okay, we're looking at taking two numbers that will multiply into negative 24. One is going to be positive and the other is going to be negative. And in terms of the weights, if you notice, we're looking at two numbers that will multiply into negative 24, one positive and the other negative. And the weights will be such that the sum or difference will be on the minus side at negative 10. So this will signal that more weight will be given to the subtraction than to the addition. Okay, and so for this particular case, right, we're going to have only x plus 2 and x minus 12. So 2 times negative 12 is negative 24, and 2 plus negative 12 will amount to negative 10. So those will be your binomial factors. And in terms of factoring, okay, just for right now, we're going to have the leading term at x squared, but we're going to make a bit of a transition from this shortly. Okay, so for the next few moments, let's see what we get in determining the factors of both x squared minus 36 and also x squared minus 12x plus 36. Okay, for what we have in these two problems, okay, we have with x squared minus 36, here we're missing a first order x term, and this is going to be a difference of squares, very much like x squared minus 64. And since we don't have a first order x term, from the difference of squares, okay, the factors will be such that you will have the same amounts added as well as subtracted. So for x squared minus 36, okay, the first terms in the factors, okay, will be x, and for negative 36, okay, you're looking at a positive and a negative 6. Okay, so x squared minus 36 will have x plus 6 and x minus 6 for the factors. So again, first case is the difference of squares. Now for the second case, okay, we have x squared minus 12x plus 36. Again, we have a bit of history to repeat with x squared going out to x and x. All right. Now with 36, okay, now 36 is a positive number, and the only ways, okay, for two positive numbers to multiply where the output is going to be a positive product is that those input numbers must either be both positive or both must be negative. And to combine to negative 12 in terms of adding or subtracting, okay, both of these factors must be negatives. So the two numbers that will multiply into 36 and simultaneously amount to negative 12 in terms of addition, turns out that they will be identical, where we have at negative 6. So x squared minus 12x plus 36 factors out to the same binomial expressions. And this is going to be yet another case of a squared trinomial. And so we have x minus 6 times itself, and condensing, okay, this will come out to x minus 6 raised to the second power. All right. Now, in the case of what we have with factoring expressions where the leading term is not x squared, now there can be some cases, let me give you just before I get to the officially the next topic, like you have like 2x squared plus 3x plus 1, and some trinomials can be factored in a way by using trial and error. So you got 2x squared, and if this is factorable, now 2x squared will go to where we have a couple of x terms, but to multiply out to 2x squared, one of these has to be 2x and the other x, and we're looking for factors of 1 that will ensure that the outside and the inside products will amount to 3x. Okay, and for this we have 2x plus 1 and x plus 1. So we've got 2x times x is 2x squared. Outside product is 2x. Inside product is at x. And combining, you will have 3x, and 1 times 1 is 1. But now, not all trinomials that have leading terms other than x squared, okay, will be quite as intuitive. And this is going to lead up to the next topic, and this is going to be in the case of factoring by grouping. And we'll start out with a case. Now you could use trial and error. But let's say that if you have, let's say you have, for factoring, we'll say we have 3x squared plus 19x plus 20. Now the easy part will come from 3x squared. Okay, so you have 3x squared will go to 3x and x. But the challenging situation will come from 20 because there are all kinds of potential combinations, like 20 might factor out to 20 and 1, 10 and 2, 5 and 4, or it might be 4 and 5, 2 and 10, 1 and 20. And but the combination should be that once you multiply out the factors, the sum of the outside and the inside products must be 19x. And to reduce, if not eliminate, much of the guesswork, okay, to start out the process of factoring by grouping, okay, we're going to look at the first and the last coefficients. Okay, so if we look at 3 and 20 and we multiply out, okay, so we're going to have 3 times 20 . So we're going to multiply the first and last numbers. So 3 times 20 comes out to 60. Okay, now in terms of where we've not used the 19 yet, and in terms of how 19 is going to come into the picture, what you're going to do is that you'll be looking for two numbers that will multiply into 60, and that will also add up to 19. Okay, and to give you a little bit of a smooth transition, okay, we just dealt with 3 and 20. 3 times 20 is 60. However, in terms of adding 3 plus 20, comes out to 23 as opposed to 19. So this is not the combination we're looking for. And 60 would factor out to like 60 and 1, 30 and 2, 20 and 3, and also you can have 15 and 4, or 4 and 15. 4 times 15 is 60, and 4 plus 15 is going to end up at 19. And this is the combination that we're seeking. And in terms of what to do with 4 and 15, okay, 4 and 15 add up to 19. And in terms of how these numbers are going to enter the picture, what's going to happen here is that the 4 and 15 will be used as coefficients that will be formed in the development of x terms upon splitting up the 19x. And it doesn't matter which term comes first. And we'll say that we have, looking at the order, so you have 3x squared, and you can say plus either 4x or 15x. Okay, so upon splitting up 19x, okay, now you can have 15x plus 4x, but in this arrangement, we have 4x as the second term, 15x as the third. Now where the grouping comes in, I'm going to put in parentheses 3x squared plus 4x and sandwiched between the first two and the last two terms, I have the operation of addition. And I'm going to group together the last two terms, which will be 15x plus 20. Okay, so grouping the first two items apart from the last two items into pairs. Okay, what's going to come next is that from the groups, I'm going to draw out, okay, the greatest common factor. Now for 3x squared and 4x, the highest term that will go into both 3x squared and 4x, that is going to be x. And x will go into 3x squared 3x times. And x will go into 4x 4 times. And we can bring down the addition. Now for 15x plus 20. Okay, now 20 is a constant. And so the greatest common factor, 15x and 20 is just going to be limited to a number. And so the highest number that will go into these terms will be 5. And guess what? Taking 5 into 15x plus 20, that is going to be 3x plus 4. And so we're going to have, in the results, if you notice from the groups, we have a common factor with 3x plus 4, and this will be one of our factors in the result. So you have 3x plus 4. And the other factor of this trinomial is going to stem from the outside terms and operations. So you have x and plus 5 on the outside. And this is going to be the result. Okay, so and you can always go back and check. So you have 3x times x is 3x squared. 3x times 5 is going to be 15x. And side product is at 4x. And 15x plus 4x will make 19x. And 4 times 5 comes out to 20. So those will be the factors. Now, something that's also another case of factoring by grouping. And we can have in the case say if we had the middle term to be a negative. Say we have 10x squared minus 23x plus 6. And just sort of going back, okay, now when we initiated the process from earlier, okay, we multiply the first and the last coefficients. And we're going to do likewise here. So you got first and last coefficients. You have 10 times 6. 10 times 6 comes out to 60. Once again, so that bit of history repeats. You had the product at 60. And now we're looking at factors of 60 that will add up to negative 23. So we're just what we have worked with. Okay. We're fresh off of 10 and 6. However, 10 plus 6 is 16. So we're not going in the right direction. And if I took negative 10 and negative 6, negative 10 times negative 6 is also 60, but that adds up to negative 16. So we need a different set of negative terms. And for this one, we're going to have one combination such that we will have negative 20 for one factor and negative 3 for the other. Negative 20 times negative 3 is 60. And adding together, negative 20 plus negative 3 is going to come out to negative 23. Okay, so you have 10x squared minus 23x plus 6. And just as I had used 4 and 15 to split the middle term, and do likewise with negative 20 and negative 3. So we're going to split up the negative 23x So we're going to have 10x squared, and we'll say we have minus 20x, followed by negative 3x, and we have plus 6. Okay. Now, for the grouping, okay, this time around, now before, we had the middle operation to be addition. However, this time around, the middle operation will be subtraction. So once we put in parentheses, okay, there's going to be a slight bit of mental gymnastics to perform. Now for the first two terms, putting in parentheses, so we have the quantity of 10x squared minus 20x. And again, we have with the middle operation, not addition, but subtraction. And for negative 3x plus 6 with subtraction as the middle operation, think of taking with the last two terms, factoring out negative 1. So you have like minus 3x would be the negative of 3x. And 6 will be like the opposite sign of negative 6. So just looking for the consistency. So if I were to remove the parentheses, first group, it still come out to 10x squared minus 20x. If I remove the second group of parentheses, I have minus 3x, and minus 6 reverts to plus 6. Now, so we have our groups, and looking for the greatest common factors from each of the pairings. We have with 10x squared minus 20x, or 10x squared minus 20x. Okay, we're going to have greatest common factor is going to be at 10x. And 10x squared divided by 10x, this will become x. And 10x taking into negative 20x, this will be a minus 2. And we can just bring down the subtraction. Now the greatest common factor of 3x minus 6. Okay, so we're going to draw out the 3. 3 is the greatest common factor of 3x minus 6. And if I take 3 into 3x minus 6, okay, that is going to be x minus 2. And looking at what we have, okay, so again we have common factors, okay, between the groupings. Okay, so we have the binomial x minus 2, and the other factor is be formed by the outside terms in operation. So we have 10x minus 3. Okay, all right, so, and you can go back and check. So x times 10x is 10x squared. And you got minus 3x minus 20x, which is negative 23x. And negative 2 times negative 3 is a positive 6. And I will mention this. If I had displayed the order where I had 10x squared minus 3x minus 20x plus 6, your shared factor would have been 10x minus 3, and your outside terms would have been x and negative 2. But you would still come out to the same factors overall. Okay, so just looking at what we have here in terms of factoring. So well, just for the next few moments. See what we get for, first of all, we'll say we have x squared minus 2x minus 80 and we'll say also 4x squared plus 19x plus 12. And 12x squared minus 13x plus 3. Okay, if you're still working on these items, that's okay. I just kind of got things sort of set up for the factoring by grouping and the second and third items. Okay, if we look into the first these items, okay, so we had the leading term at x squared. Okay, so that will factor out to x and x. And for negative 80, we're looking at two factors of negative 80, one of which will be positive and the other negative. And it'll be such that the sum or difference will be at negative 2. So this will signal that more weight will be given to the subtracting than to the adding. And so for there to be a difference of negative 2, okay, that means that we're going to have x plus 8 and x minus 10. Okay, so you have x squared minus 10x plus 8x, which will be negative 2x, and 8 times 10 is negative 80. All right. Now, for the second and third items, okay, we'll be looking at the factoring by grouping. And for number 2, okay, we have 4x squared plus 19x plus 12. Okay, so again, looking at beginning with the initial step of multiplying the first and the last constants. Okay, so you have 4 times 12 is 48. And upon attaining the product, okay, we'll be looking at factors of that product that will add up to 19. And again, we just work with 4 and 12. However, those numbers add up to 16. And if we're looking for the right combination that will multiply into 48 and add up to 19, well, those numbers, it's like we'll have 3 will go into 48 16 times, and 3 plus 16 is 19. And so the 3 and the 16 will be used to split up the 19 in the middle term. Okay, so just taking what we have here. So we have with our two terms, it could be 16x plus 3x or 3x plus 16x. And upon splitting up the middle term, okay, we're ready to group the first and the last pairs in parentheses. Okay, so we have 4x squared plus 3x. And once again, we had the middle operation to be addition. And we have grouping together the last two terms, so we have 16x plus 12. Again, so we still have 4x squared plus 3x plus 16x plus 12. And taking the greatest common factors of each of the pairs. So for 4x squared plus 3x, now the greatest common factor is going to be at x. And x into 4x squared, okay, so this will go 4x times. And x into 3x is going to be 3. And bringing down the addition. And for 16x plus 12, okay, the greatest common factor of 16x and 12 is going to be a number, and that number is going to be at 4. And as we look at taking 4 into 16x plus 12, we're also going to have 4x plus 3. And so for what we have in the case of the overall result in factoring 4x squared plus 19x plus 12, one factor is going to be that binomial that is shared between the groups, so that's going to be 4x plus 3. and the other one is going to be formed by the terms on the outside and forming its own binomial, whereupon we're going to end up with x plus 4. Okay, so those will be your factors in the mix. All right, and for what we have in the third item, we have a 12x squared minus 13x plus 3. Okay, now again, multiplying the first and the last coefficients, we have 12 times 3 is 36, and those factors add up to 15. Now we're looking for a combination that will add up to negative 13 instead. So for this one, we need both numbers to be negative, and we'll say that we have negative 9 and negative 4. Negative 9 times negative 4 is positive 36, and in terms of adding, negative 9 plus negative 4 is going to be negative 13. And so splitting up the minus 13x into x terms with negative 9 and negative 4 as the coefficients, okay, we'll have in rewriting, so we'll have 12x squared, and you can say minus 4x minus 9x, or minus 9x minus 4x. And looking at grouping, so for the first two terms, we have 12x squared minus 9x, and again, we had to be careful where the middle operation is subtraction. Once we use parentheses to represent negative 4x plus 3, I'm factoring out essentially negative 1. So we have minus 4x is the opposite sign of 4x, and 3 is going to be the opposite sign of negative 3. Again, removing parentheses, got the same first two terms, and then got the negative of 4x, and minus negative 3 becomes a positive 3. And now, drawing out the greatest common factors, for 12x squared minus 9x, both of these are variable terms, so the greatest common factor is going to be at 3x. And 3x into 12x squared minus 9x, this is going to be 4x. And 3x into negative 9x is going to be a negative 3. Bring down the subtraction. And the greatest common factor of 4x minus 3 is only going to be at 1. And 1 into 4x minus 3 is still at 4x minus 3. And so for what we have in the result, we have a common binomial with 4x minus 3. And for the other factor, this will stem from the outside terms, whereupon we have at 3x minus 1. Okay. And that will be the final result in this particular case. All right. And just some items to go ahead and be looking into. Okay, so you have on page 41. This is not to turn in, sort of like for practice. On page 41, you go ahead and be looking into numbers 77, 87, 91, 94, 102, and also 106.